multicast is now starting. All attendees are in listen-only mode.
Good morning, everybody, and welcome to the Moxlab webinar, where we're going to do an AV over IP review, and then we're going to illustrate how with the new revamped Moxlab product line, you can address any kind of AV over IP system design that you wish to implement, either in your customers or in your own facilities. My name is Jose Mozota. I'm the president of Fremen Solutions. I'm a one-man show doing training for AV professionals. I hold a CTS and a CTSI certification. I'm on the AVIXA faculty staff for training. And I also have certifications as an HD-based authorized trainer, a certified design partner for SDVOE, and I'm Dante certified to level 3. And let me tell you, we're in for a very, very interesting ride today. The goal of this webinar is first to provide you with some technical information. Moxlab and myself believe strongly that the more you understand the technology, the better the decisions that you're going to make. So we always include a very strong technical component to our presentations. We're going to learn the importance of AV bandwidth when it comes to IP transport, because we're going to come to the conclusion that the main thing that, let's say, leads to you to a solution that is going to transport AV on a network is the bandwidth of the signal and how you're going to deal with it. Then we're also going to review some IT concepts that are relevant to management and transport of digital AV signals. Although you don't need to be an IT professional or an IT expert to implement AV over IP, having a minimum set of skills related to IT will allow you to manage your system, troubleshoot your system, implement your system better. So the whole idea is to provide you with the tools so that you can do design and implementation correctly. And finally, after we learn all these things about AV over IP, we are going to review the solutions that as Moxlab we can provide to you so that you can choose, choose the right solution for your application. And please participate. There are no wrong questions. Write your questions on the chat. We will address all of them. If we run out of time and there are still questions, we'll reply to them via email, or you can contact us after the webinar. So our agenda is number one, why do we even talk about AV over IP? The next point is going to be, why is bandwidth important? How do we measure it? And how do we compress signals to be able to put them into the network? Then we're going to look at some networking concepts, and we're going to make a sidetrack into one protocol for transport of AV signals on the network from SMPTE 2110, because it's extremely relevant to Pro AV today, even though it is a broadcast kind of protocol. Finally, we're going to discuss what we refer to as the AV over IP triangle, where we're going to show you how there are different components every time you make a solution for AV over IP and how they correlate with each other. And at the end, like we said, we're going to review the Moxlab AV over IP solutions. But why don't we start with a little bit of controversy? There's a lot of talk on the media everywhere. You hear AV is IT, they have converge, IT it's AV. Well, I just want to make it clear, AV is not IT. As AV professionals, our job is to create content, to edit that content, to rearrange that content so that it's going to be a good experience for the people that will consume the content, and to bring that content to the people that need to see it. IT definitely is not AV. IT, it's all about networks, and we have been working using networks for a long time. They cover the globe. That's how we connect on the enterprise house. That's how we connect on internet outside the enterprise. So IT is definitely not AV. What IT provides us, what TCP/IP provides us, is with a transport method for an AV signal. And think about it, it's not any different than just doing a point-to-point with an HDMI cable. You have a source, you have a display, and you want to take the source to the display. You can do it with an HDMI cable, you can do it with DisplayPort, you can do it with HD-based, you can do it with even the old DVI. There's many ways that you can do that, and one of the ways happens to be utilizing a network. Now, as we're going to see, That provides you with an extra set of properties, with an extra set of features that make it very attractive as a transport method, to the point that nowadays probably half the systems that are installed are over IP, and if you go to larger deployments, it goes up to 70–80%. Now, is AV over IP relevant to you? Well, I hope that the fact that we have quite a few people in this presentation, over 100, thank you for being here, indicates that it is. This is a survey for commercial integrator. The link for the survey is at the bottom, and you will get a PDF of this presentation from Moxlab, so that you can go and check that survey. That was done with people that are doing actually installations and integrations of AV systems. And like you see, the question was, what percentage of your install in the past year, that was 2022, have included AV over IP products? And actually 12% of the people were working exclusively almost with AV over IP products, 18% at least half to 75%, 23% at least 26 to 50%. A few people, about 45%, actually a significant portion of them, had not done a lot of AV over IP. Well, maybe their vertical doesn't lend itself to AV over IP. Maybe the applications that they work with do not lend themselves to AV over IP, because like I said, on AV transport, there is not one solution that fits everywhere. Every application has its own solution that is the correct one for that application. Now, are you ready to fully embrace AV over IP? Well, more than 50% are ready to embrace it. About 25% still had concerns, and I hope that this kind of education that we provide in this webinar, like other people do, will help people to allay those concerns and start utilizing more and more AV over IP. And why do you want to do it? Well, it is flexible, it's expandable, it's convenient, and it's cost effective. Why do we mean by that? Well, the first thing that comes to mind to myself every time I think about AV over IP is remote management. If I'm displaying a source in a display on a point-to-point or with a matrix switcher, and I decide that I want to change the sort or the display in which I'm showing it, I need to physically go somewhere, unplug and replug cables, and obviously that's a limitation of those systems, but they have their applications. However, if I'm doing it over the network, I can be sitting in a room in Montreal, for example, for all the restaurants of La Cage aux Folles, the well-known Quebec sports bar, and I can be controlling all their displays. I can be controlling all the streaming at the bottom of their main screen of all the beers that they have on tap from that location. And if I want to do anything, I want to change anything, I don't need to go there. It's easy to install. Yes, networks are very well known. There's a lot of professionals that can set up a proper network that it will work perfectly. And adding AV to a network is relatively easy. You can go, as you will see from the array of products that Moxlab will offer, from, let's say, plug and play. You just plug it in and it works. And obviously, the more you know how it works, the more you understand the networks, then the better you are if you want to make modifications, if something happens and you need to do some troubleshooting. But the initial installation is relatively easy. You can also have different latency solutions. Every time that you have transport, you're going to take some time to do that transport, especially if you're doing compression. And in some cases, you can accept latency. In some other cases, you cannot. So you will see that there is a range of latencies that we can address with the Moxlab product line that will allow you to select the correct one. Digital signage over the network is just an incredible application, especially one of the trends for 2023 that digital signage is talking about is using the cloud. So you're going to put your material on the cloud, your sources on the cloud, and then you're going to be able to control that and send it anywhere, anytime, whenever you want, to any kind of device that you want to send the digital signage for your customers to consume that digital signage. So there are many, many reasons why AV over IP is very relevant. And one of them, not highlighted here, but very important, is multicasting. The ability to do one source to many displays. That's something that you cannot do with point-to-point. And with AV over IP, it's extremely easy to send just one source to as many displays as you would like to. So we really need to be looking into AV over IP as a great transport method for AV signals. And if you want to do it, let's say you decided, okay, you convinced me, I want to do AV over IP. What do you need to know? What do we need to know if we're going to be working with AV over IP? Well, in the center of AV over IP, there's no doubt about it, there's a network, because the network is the one that is going to do the transport of the AV signal. Do you have to be an IT expert? Do you have to know a lot about networking? Not really, but obviously the more you know, the better you are. Now, one thing that I want to make clear from the beginning, the network, I'm sorry, couldn't care less that you want to do AV transport. The network treats the AV solution that we're trying to transport, the AV content, the same way that it treats an email, that it treats a file transfer, that it treats an IP address assignment. For the network, these are all zeros and ones that are traveling through either copper wires or fiber optics or wireless radio signals. Doesn't make a difference to the network, okay? And that's something that you need to have very, very, very clear. So as an AV professional, the first thing I need to know is, how do I get my content into the network? That is the key. I have a network and I need to get my content in, and we're going to talk about it. Once the content is inside the network, it would be good to know how does it travel. Now, manufacturing solutions like Moxlab will allow you to get the content in, and then we take care of how does it travel. We do the necessary software work to guarantee that it will travel, and also that it gets a special treatment. Because I said before, the network doesn't care if it's an email or if it's an AV signal, but you know, networks have ways to provide different special treatment for certain kind of communications. For example, if you're doing voice over IP, the network knows that you cannot be waiting to talk to somebody because an email is coming through, so you get a special treatment. That's called quality of service. So the good news is we have the ability to implement a special treatment to get your signal through the network in the way that you want it when you need it. And the best news is that the manufactured products like the Moxlab products will have that special treatment implemented when it's necessary. And finally, once it gets to where it has to be consumed, how do you get the content out of the network? And that again is part of the solution that you will get when you get equipment to put the signal into the network, and you get equipment to take the signal out of the network. Now, when it comes to the signal itself, the main factor determining what you need to do to a signal to get it into a network is the bandwidth of that signal. You're probably aware that in the enterprise, we run 1 gigabit networks. That is more or less the norm. And about 40% of enterprise networks nowadays are running on the 10 gigabit side. It's a well-established technology. It's relatively easy to implement, and it's gone down in price enough that many people use it to future-proof their implementations. Now, no matter if it's 1 gigabit or 10 gigabit networks, we're going to show you in the next slides that an AV signal can have a bandwidth that exceeds those numbers. So you need to do something to be able to put that signal into the network. The first thing that has been done for a long time, it's called color compression. That's something that the production studios will do when they produce content, simply because they know that that content has such a large bandwidth that even without going into the network is difficult to handle. Even just to show it point to point, it can be difficult to handle because of the bandwidth that it has and the transport methods that we have available. Now, what do? Well, they use a color space called YCVCR, in which you separate the contrast of your signal, and we call it luma, from the color on your signal that we call chroma. And one of the things that the scientists discovered and communicated to the production people very early on was, do not mess with the contrast. Don't touch the luma. Your eyes are very, very sensitive to contrast. If you start reducing the contrast of the signal, people are not going to like the movie, they're not going to like the video, they're not going to like the experience. So don't mess with the luma. Now, you know what? You can do whatever you want with the color. Apparently, our brain has this ability to, especially with moving images, to imagine color, to fill spaces where color should be that it's not. We don't even know that it's happening. So we can get rid of some of the chroma. When a signal is actually taken as it's being produced without any modification, that is called 444. That's the standard nomenclature for a signal that has been produced, and it has all the chroma and all the luma content that the original production wanted it to have. Now, as we start taking out colors, we go into the 422, 411, 420 type designations that you have probably seen in brochures when people say, my system can do 4K 60, 420, or my system can do 4 to 60, 444, 8 bits. So you have seen those numbers before, and hopefully you knew what they meant. Otherwise, here you have the explanation. And 420 is an interesting one because you get rid of 75% of the color. So you get rid of a lot of the color information, and you're wondering, how does that work? Is it actually possible that that signal is still acceptable to the viewer? Well, you've been experiencing it for many years. All the DVD and Blu-ray players that you have ever watched have all day been on 420. The only way that you will see 444 is if you work in the production studio, or if you go to a trade show and somebody has 444 content with a short HDMI cable connected to a display for you to appreciate what 444 means. The rest of the world, you'll never see 444, not even on a movie theater. On a movie theater, you're going to see 422. You're even going to see 420 for the digital movies. So amazingly enough, this works very well, and we can reduce the bandwidth by 50% at the production studio level just by doing color compression. Now, how do I calculate the bandwidth of a signal besides looking at the color compression? Well, when I transport an AV signal, what am I transporting? Well, I'm transporting images, and those images have a certain resolution, and that resolution means that I need a certain number of pixels to reconstruct or create that image. So the number of pixels is the horizontal and the vertical number of pixels. If I multiply those, I get the total number of pixels I need to transport. Then how often do I send that image? And that's the frame rate. In North America, typically 24, 30, 60, very special cases 120, but let's leave it at that. Then besides sending that image for so many frames per second, how many bits am I going to use to communicate to the device the color that is contained on each one of those pixels? And that's called the color bit depth. When we had high definition, we use 8-bit color. With 4K, we introduced 10-bit color, 12, 16-bit color. And by the way, 10-bit color is required for HDR. You cannot have HDR if you don't have 10-bit color. So you multiply them by that color bit depth. And then how many graphics channels are you sending? Because you have to send information about red, green, and blue. Or if you're using YCBCR, you have to send information for luma and the two chroma components. So when you multiply all that, then you add an extra factor, which is the chroma subsampling or the color compression. If you have a 444 image, you multiply by 1. There's no reduction in bandwidth through chroma subsampling. But if you have a 420, you multiply by 0.5 because you have reduced the total bandwidth in half. And let's see an example of a calculation here at the bottom. 4K UHD signal. 4K UHD means 3840 by 2160 pixels at 60 frames per second. So I multiply by 60. 8-bit color, I multiply by 8. 3 because there are 3 graphic channels, and 1 because it's a 444 signal, so no chroma subsampling bandwidth reduction. And look at the number, 12 gigabits per second. So I just show you a signal that is not that, let's say, complicated in the sense that it doesn't even have HDR, 10-bit color, and it already exceeds the highest bandwidth of a network that you're going to find on the enterprise. We find 1 gig, we find 10 gig. You can find a 25 gigabit network if you're going to production broadcast studios, and you can understand why. In order to carry 444 signals inside the studio with the 8-bit and more 10-bit, 12-bit color, you need more than 10 gigabits. So they use 25 gigabit fiber networks. And after that, you're talking about data center world with 40 to 800 gigabits per second. And yes, there are switches nowadays that carry 800 gigabits per second on the data center. Now, this chart from the PDF that we will send you is probably one of the most interesting pieces of information that we're showing here. This chart shows you the bandwidth of signals based on resolution, on the bit depth, and on the frames per rate. We have here HD 8 bits 30 or 4K 8 bits 30 or 4K 8 bits 60 and even 8K signals. So I have calculated all the bandwidth for those signals based on a 420 signal. That means a signal that had the chroma subsampling applied to it to reduce the bandwidth by 50%. If you want to know the bandwidth of a 444 signal, just multiply by 2 any of the numbers that you see there. I also included a 1 gigabit network level, and as you can see, there's nothing we can put on a gigabit network without compression. I also included the 10 gig network level, and that's a better situation. We can do quite a few things with a 10 gigabit network when it comes to sending signals in without further compression, because those have already color compression. But I also included, just to talk about it, the HDMI 1.4 level, similar to the 10 gig level, the 2.0 at 18 gigabit bandwidth, and the new 2.1 release at 48 gigabit bandwidth, just to show that in case that you want to do a point-to-point of a 444 image with high resolution and with high bit content and with high frame rate, because that's the application that you require, then point-to-point may be your best bet. But if you want to do it with a network, then you're going to have to take into consideration the limitations of the bandwidth of the network. Now, that was about video. Do we have to worry about audio? Very quickly, the answer is no. Audio, even at the sample rate of DVD quality, 192 kilohertz, which is more than the required by Shannon and Nyquist, at 24 bits per sample, which is a ridiculous amount of detail on the information of the signal. And nowadays we can even go to 32, even 6 channels, 5.1 channels of audio. The signal only gets to about 27 megabits of bandwidth, which is really nothing compared to the capability of a network to carry bandwidth. So bandwidth is not an issue for audio over IP. Compression, it's only relevant when we want to store it. So we don't really compress audio signals. However, if we want to put songs inside a device like an iPod, an iPhone, etc., then we compress them because we can put more songs in there. And the way we're going to listen to them with headphones, the quality of the audio is going to be very, very acceptable. As you know, also, audio over IP was the first thing that we put on the network as AV professionals. We transported audio with Ether Sound, with CobraNet, and nowadays with Dante, Q-SYS, AVB, etc. And those applications are the simpler ones to do, simply because the audio is a very low bandwidth signal compared to video and compared to what a network can handle. So that's essentially the representation of what we need to do to get our signal into the network. We may have signals that are analog, and typically audio starts analog, and then we need what I call here a black box, which will convert that analog signal to digital. As you learn more about these boxes, this would be a pulse code modulator encoder, essentially an analog to digital converter that would be part of any solution that allows you to introduce audio into a network. The first step will be to turn the audio into a digital signal, and that digital signal will have quite a few zeros and ones. Let me explain it that way. You know, only at the megabit range, that's still millions, but quite a few only, compared to if you have digital video that has a lot of zeros and ones. So after that, and even before we go into the network, we're going to have to compress that signal. We're going to have to get rid of some stuff on the signal to lower the bandwidth so it can go into the network, and we have to do it in a way that the experience for the consumer of the content is not going to be impacted by the compression. So that's the whole trick about compression. That's why companies make money when they create compression codecs, because they learn how to eliminate components of the signal, reduce the bandwidth, but at the same time allow the experience to be good for the consumer of the content. So we go out, we compress that signal, and then we put it into our network interface card. There's an encoder in there that is handled by the electronics in the network interface card that will send the zeros and ones into the wire or into the fiber or into the radio signal to put it wireless. Now, what are the typical compression codecs that we have available? There are hundreds of them. There's a lot of them that are designed for specific purposes. There are companies that are specialized in boutique codecs for your specific application, but there are also some that are the standard of the industry. There are some that are open. You can see the code, you know how they work, and those are the ones that are typically implemented. So I'm going to show in this chart the compression codecs, and I'm also starting to put as a reference the Moxlab product families that are related to those codecs. So if you have a 10 gigabit network and you just want to reduce your signal to around 9 gigabit to put it into a 10 gig network with the best possible quality of the picture, with the lowest possible latency, but with the highest bandwidth, then that is the SDVoE Alliance type of compression, the Blue River NT, and that is the 400 series family of Moxlab. That's called lossless by the SDVoE Alliance. I have a gripe with that. There's nothing lossless when it comes to AV compression. You always lose something, so it should become visually lossless. Then what are called visually lossless by the industry in general, those are codecs that give you relatively high bandwidth, close to 1 gigabit. Although you can play with the box, you can tell it, give me less bandwidth, give me more bandwidth, but you typically run maximum at around 800 megabit. Those are called visually lossless, and that means that they are subjective to the judgment of the viewer. So people see it and they say, oh, this really looks visually lossless. I don't see that you lost anything. So that most typical one that you will find is the JPEG 2000. And if you want to implement that kind of solution, then the series 200 and 300 of products of Moxlab will allow you to implement it. We'll talk about them later. And finally, let's say that you have a situation where you need a very, very, very high compression rate. You're going to be streaming over the internet. You have situations where the quality of the image, it's still good, but it's not as good as the other ones, but you don't mind. The latency doesn't matter to you because the more you compress a signal, the more latency you introduce. The algorithm takes time to be run in the electronics. So in that case, you end up with something like MPEG-2 or the H.264, H.265 series, which would be equivalent to the 100 and 600 series of products for Moxlab. So as you can see, you do have a choice when it comes to compression, and your choice has to be related to the particular application that you want to implement. If I'm going to do a medical, let's say, system to look at MRI images over a network, then I want the minimum possible amount of compression because I don't want to lose any detail of those images. So I'll probably do an SDVoE solution. If I want to do a sports bar where people are going to be watching to those screens hanging from the ceiling while they are drinking a beer, then I'm going to use probably an H.264, H.265. If I'm going to go over the internet, I'm definitely going to use H.264, H.265. By the way, this presentation right now is done with probably an H.264 compression from GoToMeeting. And if I have an intermediate situation where I want a certain amount of picture quality, but you know, I'm willing to stress a little bit more my network, then I'll probably go with the JPEG 2000. At the end of the day, it's all going to be about the application. So that's regarding the bandwidth of the signal, and I hope that by now we agree that the bandwidth of the signal is the one that is going to determine which compression are we going to use. Let's look at one or two issues related to the IT and to networking that you should be familiar with. Number one is how the two different kinds of networks operate. The local area network or the LAN, and the wide area network or the WAN. The local area network is the network in your enterprise, is the network in your home, is the network that only has switches, is the network that only collects to a router when you want to get out of the house, if you want to do streaming, but the rest of the time, many of the applications of AV over IP are actually done on the LAN. They never have to leave the one because you don't need to do streaming. You don't need to send it anywhere else in the world. It's all in the house. If you're in a casino, if you're in a convention center, even if you're in a stadium, besides the production truck that will take it out, all the displays, everything, all that is done in the local area network. And what is the characteristic of the local area network? That we know its capacity because we design it, we build it, we construct it. It has very low packet loss. It has very low latency. So essentially, I don't have to worry about anything when I want to work on the local area network. However, in many cases, I want to get out of my house. I want to do streaming, real time or not. And that means I have to send my signal into the internet. And that's when the problem starts. The internet, you don't know the capacity. The internet can be busy. The internet can be less busy. So you never know what problems you're going to be finding on the internet, what routes are down, which routers are working, which are overloaded, etc. You're going to have packet loss. There's no doubt about it. So you're going to have to look at ways in which you can try to recover if that packet loss is too big. You're also going to have jitter, where the frames, the packets arrive in different order that they were sent, and you're going to have to recover that ordering, and you're definitely going to have high latency. And I really mean high latency. I watch, for example, soccer. I'm a fan of Barcelona, and my son watches soccer in Denver. We have different providers, and sometimes there's 20 seconds different between his signal and my signal when we're watching a game. So one of us sees the goal 20 seconds later. Does it matter to me? Not really, because I'm not in the stadium. So at the end of the day, I'm not betting on when the goal is going to take place. So I'm just enjoying the game and the fact that I'm not in Spain, but I can still watch the game from my home in Canada. So there is high latency on the wide area network. Does it matter to you? If it does, then there are ways to go around lowering that latency or choosing solutions that will provide you lower latency, but that would be the subject of a whole webinar or two by themselves. Now, one of the things that you're really going to have to do when you're setting up a network for AV over IP is to choose the switch. And sometimes people ask me, should the network for AV be separated only for AV? Can it be on the production network? And the answer is yes and yes. The main or the most important way of thinking about it is what else is it going to be on the network? It is better to have the network only for AV simply because our bandwidth is very high. And if we try to put that content on a regular network, then the other services on the network are going to suffer because we have high bandwidth and we have ways to say that that bandwidth has priority. So the rest is going to have to wait until we are done. So the best recommendation is always to have your standalone network. And in many of your applications, many of your customers, many of you as end users actually have relatively smaller systems that can use only one switch. So you may have to make your networking decisions yourself without the help of an IT person. And here are some tips as to how to look for when you're looking for a switch for AV. Number one, you want your switch to be layer 2, which is a switch. And you also want the switch to be layer 3. And that means you want that switch to be capable of routing signals. Why do you want to do that? Because you also want a managed switch that allows you to do virtual local area networks. Typically, you're going to separate the services in your own AV network, for example, into audio, video, lighting, control, and all of them are going to be in their own virtual local area networks that cannot talk to each other unless they use a router. So if you have a switch that has routing capabilities, that will allow you to communicate between the different virtual local area networks. For example, the control network can have access to all of them. The second thing you want is you want switches that are fully non-blocking. What do we mean by that? When you look at a switch and you see all the ports in the switch, you can connect something to all the ports. So all the ports can be used, for example, on a 48-port switch. So theoretically, you could have 48 ports at 1 gigabit, for example, each of sending and 1 gigabit receiving, which means 48 times 2. So that's 96 total bandwidth, gigabits of bandwidth going through the ports at the same time if the ports are working at full bandwidth. And not all the switches are built that the electronics on the switch, what is called the fabric of the switch, allows you to have that happening. And that's not a problem on the enterprise, because on the enterprise, signals have very low bandwidth. So even if all the ports are working at the same time, they never overload the switch. With AV, it would be very easy to overload the fabric of the switch unless it is non-blocking. And non-blocking means that all the ports can operate at the same time at full bandwidth. So for AV, always get non-blocking switches. You also need switches capable of running IGMP, Internet Group Management Protocol. Without IGMP, there is no multicasting. So if you want to do multicasting in your system, you do need to be able to run IGMP. And although we like to think about the environment and we try to buy green electronic equipment, green switches are not a good idea for AV. They're a good idea for the enterprise, but green switches, what they do is the ports go to sleep when they are not being used. And when they get a communication, they have to wake up and process the communication. That wake up time, it's latency, means delays. That especially is very bad for audio. So avoid green switches when you're dealing with AV in your installations. And one point that you should learn more about it is the fact that if you have more than one switch, because you need the port count or you need the distance, you have to go from one place 100 meters to another switch and then 100 meters to another switch because your conference center is big or your casino is big or your bar is big or whatever, and then you need to interconnect those switches. That's not plug and play. Essentially, you need to understand what you're doing when you're interconnecting switches. You need to learn about stacking, you need to learn about uplinking, and you need to learn about link aggregation protocols. So if you're going to be interconnecting switches, either you learn that or you get some people with IT knowledge on board that can help you with that, because it's very easy to make a wrong network configuration for AV when you don't understand how you need to link the switches, because of the fact that our signals are very, very high bandwidth and they can easily overload the interconnecting links. And the last thing that I want to mention about AV over IP on the IT side is one particular transport protocol that has been born from the broadcast production industry, which is SMPTE 2110. Most of you are familiar with broadcast production, so we have always used SDI connections for our audio, video, ancillary, and timing, and that was put as a one signal into our system with the SDI connection and coax cable, and that worked very, very well. As IT became a transport method for AV, obviously production broadcast jumped on the one wagon and started looking into it, and they did SMPTE 2022.6 just bringing the whole signal into the network, and that worked very well for them. And then they thought, why don't we do something even better? And this is actually extremely creative. They separated the signals into different packets. So they took the audio content of the signal and put it into an audio packet. They took the video content and put it into a video packet. They took the ancillary content like subtitles, advertisement, etc., and put it into a different packet, and they kept the timing in a different packet so that they could transport those packets separately on the network, and that gives them the ability to extract that packet from the network, process it if they need to, and then reinsert it in the network with the guarantee that the timing packet will keep everybody synchronized. So let's imagine that you want to work on the audio. In the previous way, you had to unpack the whole stream, work on the audio, repack the whole stream. Now you only take out the audio packets, you unpack the audio packets, do your DSP or whatever processing you want to do on it, repack your audio packets, put them back on the network, and they go and they get together. These are referred to as essence stream because they are the essence of the transmission, the essence of the production. The reason I'm showing it to you is because Pro AV is starting to use this type of packets, different packets for audio, video, and ancillary to change their workflow. So this applies not only to production And broadcast, it's also applying to Pro AV, where professionals are finding creative ways of using the fact that these packets are separate. And as Moxlab, we've always been very heavily involved with production and broadcast. We also have a family series, the 800 series of products that will allow you to do that. So if you want to experiment with what 2110 can mean for you, we have a solution that you can utilize. So finally, what is that AV over IP triangle that I referred to? Well, every time you're going to do a network design for transporting AV signals, you're going to have three parameters that are going to be interlaced with each other. One is the bandwidth, the other is the video quality, and the third one is the latency. And of course, in the middle is the dollar sign. So if I have a network that can handle high bandwidth, like 10 gig, and that means I'm going to have a very high video quality because the compression is going to be very low, and my latency is going to be very, very small because there is almost no compression, and the rest of the network doesn't add a lot of latency. But you know what? It's going to cost you a lot of money. I mean, not a lot, but more than any other solution, because the 10 gig network is more expensive, and the systems to do this little compression at low latency are also a little bit more expensive. However, if I'm willing to go with an H.264 system with extremely low bandwidth, and by the way, remember that you watch television at 3 megabits per second with H.264 compression, and it looks pretty good, right? So if you're willing to do that, the video quality will still be acceptable, but it will be less than with the previous case. However, the latency will be a little bit higher, so you have to say if you can accept that level of latency, but you're going to be spending less money than with the previous solution. So there's no two ways around it. These three parameters are interrelated, and the amount of money that you're going to spend is going to depend on the decision that you make related to those parameters. So this slide kind of summarizes the puzzle that you have to solve. You have content that can be high definition 4K, and maybe one day we'll have 8K content. You have consumers that are actually accessing your content on a display, on a PC, on a tablet, on a smartphone, on any kind of devices. They want to bring their own device. They want to do it whenever, however, okay? And you have gigabit networks. You have 10 gigabit networks, a little bit more expensive. And if you are on the production world, you have 25 gigabit networks. So what choices do you have? Well, if you're working with a gigabit network, you could go for a very high compression rate with H.264, H.265, and NJPEG. And that will be the 100 and 600 series for Moxlab. And that will give you the lowest level of bandwidth possible, highest latency, and lowest picture quality. Or you can go to an intermediate stage with JPEG 2000 with the 200 and 300 family series, and you will get a little bit higher bandwidth up to the 1 gigabit that your network can carry, but you will get actually better video quality, and you will get less latency. But if you're investing on a 10 gigabit network, then you get the 400 family series with the Blue Reverse NT technology for compression, and that will provide you the best possible video quality, the highest bandwidth, and the lowest latency. And if you want to play with the 25 gigabit network or with any of these networks, separated the signal into the essence components, then you can go with the 800 series. Okay. So I hope that that gave you quite a bit of information on the technology behind AV over IP. Now let's see how we at Moxlab can help you turn that into a solution for your customers, a solution for yourself, something that you can be proud of. Well, imagine the fact that with AV over IP, we can access and control systems from anywhere, and all the solutions will work flawlessly because they are designed to be able to put the data into the network, to handle the data in the network, and to get the data out of the network. Doesn't matter what kind of vertical you're in, from home theater, classrooms, digital signage, storeroom systems, security, sports bar, medical image broadcast, all these have the possibility of using AV over IP. Which one of the families you're going to select for your solution is going to depend on the particular needs of your application. And not only do we provide the solutions that will allow you to fulfill your implementation, but also we work with leaders in the business when it comes to control and to switching. So with control, we work with Q-SYS, Crestron, Control4, RTI, and URC, and with switches, we're compatible with both NETGEAR and Cisco, but we have gone one step beyond and we have become NETGEAR partners. So to become NETGEAR partners, we tested all their equipment for compatibility. We learned enough about it to support it in case that you implement it and you have an issue. The switches that NETGEAR is designing today in the market are unparalleled in their ability to be used for AV. They have something called IGMP Plus that is exclusive to NETGEAR that makes it very easy to do multicasting. They have the NETGEAR Engaged software with profiles that you just click on the profile and it loads the switch with everything that you need for that particular AV application. If you're running Dante, if you're done running video, if you're running RTMP, whatever you're running, there's a profile that you can easily load and it's really plug and play. And those switches are available through Moxlab. So we have two models, one with 8 ports, the other with 24 ports, both of them PoE enabled and both of them capable of linking with copper or fiber. And finally, NETGEAR, most people don't know it, has a Pro AV design team that you can contact and they'll design the network for you for free. If you tell them what you need, they'll give you a free design for your network, obviously with their switches. So this partnership with NETGEAR is quite interesting for us at this point, and I hope also for our customers. And then when it comes to control, Q-SYS is kind of a leader on the control arena. Many of our customers work with Q-SYS and they have been asking for us to be able to connect with Q-SYS seamlessly. So we ended up being a Q-SYS technology partner. That means we have a fully vetted AV over IP manager by Q-SYS, and our plugin works with the digital network controller that will allow you then to interconnect to any Q-SYS control system. Once you do that, you just write your simple APIs and you can send RS-232 commands, you can route video walls, you can apply presets, you can do whatever you want, and everything you do will work seamlessly with any Q-SYS system. Now, let me show you a typical AV over IP arrangement, one that looks simple, and to tell you the truth, AV over IP, it is simple. You can make it as big as you want, but at the end of the day, it has two simple rules. One of them is one transmitter per source. Anything that I need to put into the network, I need to connect it to a transmitter. What does that transmitter do? Analog to digital, if it's an analog signal, compression to the level that you want it, and then encoding to put it into the network. Then you have your network here. We typically have a network controller that we can connect the PC to the network to control everything we're going to do. We may have a wireless router also to allow people to connect wirelessly to that network, but also for us to use an iPad or an iPhone with the Mox Control app that allows you also to control the network with that kind of device. And then the second rule is one decoder for every display. So every time I encoded the signal to get it into the network, I need to decode it to get it out of the network. So one transmitter per source, one decoder per display. And you can make it as complicated as you want, but that at the end of the day, it's all there is to it for AV over IP. As Moxlab, we take care that the encoder and the decoders will be discovered by the controller, that you'll be able to control them, that they will put the signal correctly into the network in the right format and with the right quality of, let's say, of service that the signal requires to get there at the right time. And the rest, it's up to you. Provide the content, provide the displays, and enjoy the application. And the series of families that we have available run from the 100 series, would be the less expensive of them all, with MJPEG compression for working over 1 gigabit, to the H.264, H.265 for low bandwidth streaming with the 600 series. If you want to do 4K 60 420 or 4K 60 444 with JPEG 2000, you can use these families, the 200 and the 300, and you can contact Moxlab sales team to get more details about them. If you want to do SDVoE, we have the 400 series, And if you want to take advantage of SMPTE 2110, we can do the 800 series of families. These are some diagrams now of implementation, and if you go to our website, you can check our products, and all of them will come with this application data and diagrams that show you how you can actually implement the product on a real network. This is, for example, a KVN solution, so keyboard video monitor solution. You may have here a keyboard and a mouse on a remote location, and you're controlling a server that is in the intermediate distribution facility. The signals, both USB, HDMI, Cat5e for the network, will be flowing in both directions here on the network, so you have total control of what you're doing over these, and you can also do JPEG 2000 compression with this kind of a solution. If you want to use the 2110 idea, which means I'm going to separate the video, audio, ancillary, and timing so that I can play with them and bring them back in together again, then we have a solution here where, for example, we have two HDMI cameras sending two different signals into the network, and we're taking them out with these two receivers into a video mixer, so then the director or the professional can actually be working with the mixer to create a new video that mixes the input from those cameras, and then that goes through return channel back into the network, so then you can use it in your monitors, you can use it in your final production. Now, not only do you get the ability to separate the signals, ST or SMPTE created in the ST 2110, the 2022-7 for redundancy, because sometimes you may lose some packets, and if you want total reliability, then these boxes give you the ability to connect to two networks at the same time. And the way this system works is that it detects the packets that are flowing on each one of the networks. If one of the packages is lost in one of the particular streams, it's picked up from the other one. The whole idea is, at the end of the day, we can provide to the output device a complete stream that has no lost packages. So this 2020 is very important. And we also implemented on these boxes NMOS. NMOS is Networked Media Open Specification. It's a new standard that is trying to be developed so that devices can be discovered and controlled on the network by anybody. It doesn't have to be a Moxlab device. It could be a product from a different supplier that does other things with the signal, and it will be recognized if it's an NMOS device. So we're trying really to bring the latest in technology to our solutions, especially when it comes to having a standardized solution, because that's one of the things we're missing on the AV world. Standards, SMPTE 2110, NMOS, etc., are trying to bring standards into the professional AV, and that's a great move, because that's what makes networks work, and hopefully it will make it easier for us as AV professionals. If you're still using SDI, we also have solutions that will allow you to take your 3G SDI signal and get it into the network to work with them. So no matter what you want to do, you can approach our sales team and they'll be able to provide you with a solution. And the heart of it will be the network controller. With the network controller, you'll be able to discover transmitters, discover receivers, and diagram which source goes to which displays. And not only doing that with a PC connected to the network, you'll be able to do it with a mobile device and a simple app called Mox Control. So, in summary, how do you implement AV over IP? Our first recommendation is educate yourself. And by being in this webinar and others that you have probably attended, that's what you're doing. The more you know, the more the customer knows, the better the decision that customer is going to make related to the implementation of a system that does what the customer wants the system to do. This education will allow you to cut through the noise. There's something that I call, I'm sorry, Lori, marketing noise, where the marketing people like to say things, and you have to understand what they are saying. So cutting through the noise means being able to understand what they actually mean when they explain to you the features of their products. Because at the end of the day, this is all about the application. You have to think about what the user needs, and what the user needs, it's what you have to provide, and that is going to determine what kind of AV over IP system you're going to implement. And finally, it's a team effort. If you're working on your own in a small network, in a small system, that's fine, you can do it. Now, if you have any issues, then you need a certain knowledge of networking in order to address them. So it's better to have people with IT knowledge on the team. Very hard to do any serious or large implementation of AV over IP without working together, professionals from the AV world and professionals for the IT world. So by educating yourself, you also learn the vocabulary to communicate efficiently and effectively with the IT professionals. Lori is going to put on the chat the link for this video. This is a short video that Moxlab has describing all these product families that we have discussed today. We found out that the connection today wasn't good enough for us to present the video to you, so we're going to put that on the chat, and we'll appreciate if you could take a few minutes to actually go to YouTube and check out that video. I think it's less than 2 minutes long, but it's very illustrative and very graphical of the different families and what they can do for you. The last thing I wanted to mention is if you're going to be working on AV over IP, you should be aware of these industry alliances and associations. Otherwise, it would mean that you're not aware of everything that's going on the industry. So SDVoE, Software Defined Over Ethernet, based in Montreal actually, Alliance, everything related to 10 gig. AVNU, it's the association of companies that implement audio video bridging. BIAMP is the leader of that, for example, for transport on the network. AIMS, the Alliance for AP Media Solution, very associated closely with Matrox Video, also in Montreal. Montreal seems to be the heart of all these things. SMPTE, the Society of Motion Picture and Television Engineers, with their 2110. AVIXA, where is the place where we bring together all the knowledge, all the manufacturers, all the users, all the integrators, and that's through ISE and Infocom. BIXI is similar to AVIXA, but it's on the structured cabling side. And if you're going to be doing networking, you better learn about structured cabling. So it's good to know about BIXI. SRT is a new alliance for a new protocol that is being used to stream over the internet and to make sure that you don't lose packages and that you can actually do good streaming over the internet. So if you're into streaming, SRT is something you should be aware of. And finally, the Audio Engineering Society is trying to make sure that all the audio over IP systems can talk to each other. They're trying to make sure that even though they are proprietary, that they have a common set of requirements so that if you implement AES 67, then they can talk to each other. And that, again, another step forward towards having standardized solutions in the world of AV. Thank you very much for listening to us. I know that it was a lot and I spoke a little bit fast maybe, but I just wanted to communicate all that information to you. And if you have any questions that you would like to contact me for, this is my contact information, but you always almost have as the first line of information the sales team at Moxlab. They'll be glad to discuss with you anything related to any of the product families that we have presented today. I hope that you got a good return on your time investment, because your time is valuable and we appreciate the fact that you decided to dedicate it to being with us here today. Thank you very much. And are there any questions?